In 1896, chemistry Nobel laureate Arrhenius raised the question of the influence of absorption of gases in our atmosphere upon climate. He specifically asked the question of whether the temperature of the ground was any way influenced by the presence of heat-absorbing gases. His findings introduced the notion of greenhouse gas and global warming by that gas, and he was the first to make the connection between the increasing amounts of greenhouse gas with the accompanying temperature rise. This was the first published research back in 1896 on the science of climate change. It sparked controversy during Arrhenius' time, and nearly 123 years later, the topic still sparks controversy. In 1958, Charles Keeling of Scripps began measuring the amount of CO2 in Earth's atmosphere. The result was the Keeling curve that many of you probably have seen that showed that CO2 levels are rising to 400 parts per million levels in nearly 50 years. Climate science today, since these pioneering studies, have since connected the temperature increase with the increasing amount of CO2, as suggested by Arrhenius in 1896. The question now is not whether climate will continue to change, but how large the change will be as fossil fuel burning continues to add CO2 to the atmosphere. If we went to zero emission of CO2, the reduction would result most likely in warming to be only less than a half a degree Celsius over the next 2 decades. So as not to repeat history, what lessons have we learned moving forward? As new industry emerge and supply the world with new innovations and new technologies, how do we ensure that those manufacturing processes do not exacerbate our environmental recovery? We have to think, and we have to be proactive in our thinking about adopting design principles that mitigate environmental impact from the beginning. Identifying the molecular origin of global warming, and you can identify this paper. You can identify this paper by Googling it. That paper laid out for the first time such a design strategy for how properties of the molecule that influence molecular absorption, which is at the heart of global warming. Principles of green chemistry also is developing important guidelines for making new materials where the processes are friendly to our environment. We have the science tools from basic and fundamental research to address the issues of climate change now. We have those tools now. But what are we doing with them? For students who are looking for how you can make a difference by contributing to new science, there's an emerging new area, and I want to bring this new area to your attention. It's called negative emission science. This science holds potential for major scientific breakthroughs. It is an example of an emerging area where there's opportunity for you to make a contribution and to have impact on the future of our environment and our planet Earth. Thank you.